For designing a modern data architecture. Access to that data is then decentralized. For designing a modern data architecture. For designing a modern data architecture. Welcome to the Data Mesh Book Club, brought to you by Amazon and Starburst. Today, we're covering book 3 in the series, and this is part 1 of book 3. We're going to have to cover it in a couple of different parts. This is a bigger book. We're going to cover the fundamentals of data engineering written by Joe Reese and Matt Housley. Now, as always, before we jump into it, we want to make sure that we encourage everyone to join our LinkedIn group. There's a QR code. You've seen it before. Most of you are already engaged. The value of joining is, one, you get to kind of ping us during the show, and we'll do our best to listen. 2, no guarantees. 2 is we will engage with you after the show, and we have a lot of great conversations, questions, challenges. It's all good. It's all about learning. All right, let's jump into this. Now, I want to welcome, and you know him as Captain Mesh. I know him as my friend Andy Mott. You've seen him on the big screen. You have seen him on the big stage, and soon you will see him in the big ring as he goes head to head with Joe Reese at Data Nova. Welcome to the show, Mr. Mott.
Thank you. I'm going to get destroyed by Joe, but there you go.
You need a good ground game. You need a good ground game, and don't be afraid to go for the choke if you have to. Hey, yeah. Andy, you and I have jumped into this book. We've gone through part 1, and before we kind of get into the details, because there's a lot of content in this book, I think it's important for us to kind of just set some context for our lens, if you will, right? I think I want to make sure that someone hasn't joined and thought that we're going to cover this book in such detail that they don't have to read it, or that we're going to go over the book with such detail that they're going to walk out of here with a thorough understanding of data engineering. That's not this show, right? I think what we're trying to do here, is kind of bring the data mesh lens to this great book, right? This, just see if you would agree with me. I would say any data mesh program, anybody who's driving a data mesh initiative, I would say they should read this book. Data engineering is a foundation for any functional data mesh, right? These are two things that need to go together. Do you agree, Andy?
I do. I think I think data engineering, as laid out in the book, and we'll get to that in a moment, is important whether you're thinking about a data warehouse, whether you're thinking about sort of a data lake or a data lakehouse approach, or indeed a data mesh. I think the way that data engineering fits in is kind of clearly different. Roles and responsibilities change depending on kind of your architecture and your approach. but the fundamentals of kind of getting data, doing stuff with data, and giving that data to people to make business decisions. That's kind of fundamental in sort of everywhere, if you will.
I'm going to go one step further before we start. I would say, so you're not a data engineer and you're listening to this, you're thinking, yeah, this probably isn't for me. I don't know. I want to go out there. At least I'll answer the same question when we do part 2 and part 3. But so far, having read part 1, I would say every CDO should read part 1. When we start talking about a data mesh, and we want to start driving that abstraction, the complexity of the architecture lens, kind of from the consumer lens, so to speak, you would say, well, I don't need to understand the back end. Mr. CDO, but yes, you do, right? I have certainly gained a lot by reading it, not necessarily because I became an engineer or a better architect, but more so because I can better understand the challenges that my engineering and data science teams are going with. If we're going to create, and that's just what Joe and Matt are trying to do here, is create a common language. If we're going to create a common language, a standard for what data engineering is, everyone, every CDO should understand that. So I think it's a great way to get started. So I'll look at it from a CDO lens. Andy, and what lens are you going to study this from?
How stuff works. So whether we call that an engineer or I guess a data warehouse developer, or an architect or a solution architect or a technical architect, or even like an analytics engineer, which I think is a new job title, which people seem to be banding around. I think it's all of those, right? I think there's something for everything in here. And so I try and think about the material that we review from lots of different lenses. So yeah, sort of how stuff works.
Well, funny you should say, you gave a long answer there about all kinds of things that sound like engineer. What is a data engineer, right? Great segue, right?
Yes.
I stole these images from a YouTube. If you do a search for the book, one of the first things that pops up on YouTube, and this is actually fairly recent here. Gosh, I'm not sure if it was 6 months ago or somewhere in that range. Joe and Matt did this great YouTube presentation, and I love they got into the fun of trying to define what data engineering is, right? And the top left here is kind of their initial answer. What do data engineers do, right? They get data from sources, they do something useful to it, and they serve it, right? That's the easiest answer. It's not about technology, it's about other things as well, right? It's more than just technology. I like this notion about lifecycle management, and we're going to get into that in a second, because as you said, Andy, as you mentioned before the show, you said that lifecycle image is core.
Yeah.
But your answer a second ago, Andy, sounded more like this one.
Yeah, and this is the long answer. I mean, I fundamentally agree with the first answer they gave, that get data, transform it, and get it to people to make decisions. But this is kind of more like the reality. And then you can dive into the definitions of all of these items. You know, what is raw data? What does that mean? What do we don't mean by high quality? What do I mean by consistent information? You know, so there's this seems like a long definition, but then you expand this out and you get like a 400-page book.
I like what happened when I first saw this. I said, oh man, they're putting a lot under the umbrella of the engineer. I even thought to myself, come on, does the engineer really do everything? But what I like, and you will see this in a slide or two, is when they come back and they start to create some real segmentation, they start to say, and let's be clear, this is our scope, this is not our scope. And I think that's one of the key elements of this first part. So let's start to kind of break into what I just described, right? The left side of the screen is where what they refer to in the book as the upstream data producers. I'm looking at the image there on the left. And that right part of that image talks about the downstream data consumers. I got to tell you, with the data mesh head on, I looked at that and I said, that sounds a lot like what we've been talking about that abstraction layer, abstracting the left side from the right side.
Yeah. So I guess an interesting point I had not considered. So when I look at this, I think actually if we were looking at this from a data mesh perspective, I'd probably like to see it's more like a 3 data engineer boxes in the middle, and almost like slices that go across that say, well, I'm gonna have some people in the upstream data producers, some data engineers, and some people who are consumers in a domain, I guess. so that's kind of my immediate thought. And actually, I guess we got that sort that at the bottom: the source system, data engineers, analytics, ML, and basically we're going to have that for each domain. And then obviously, but on the flip side of that, what this also highlights is kind of the complexity that's going on in a domain, right? Because actually, you may have software engineers, you may have data architects, you may have DevOps people, you know, you may have governance people on that kind of left side. And you may have all these different consumers on the right-hand side, and you may have a bunch of engineers in the middle, and that all of those may sit into a single domain, right?
Yep.
So I think there's a few ways of looking at this with a data mesh hat on. You know, there's ways of presenting it, I guess. So yeah, it's quite an interesting.
It's screamed operational versus analytical pains to me. And then I quoted, and you'll see throughout the slides, I did my best to give credit to the authors by giving the page number and so forth. I don't want anyone to think that's us. But when I quoted some pieces and I highlighted some parts that I thought were really interesting in this data science hierarchy of needs, I think it's on page 12. I think it's not a surprise, but it's great that they call it out very early, right? The challenge that we have, and we also see this in Jamak's book, calling it out. The idea that the consumers are spending way too much time. This is 70 to 80%. That's high. And I don't challenge it, but it's a bit shocking. They're spending way too much time on the lower layers of this pyramid, right? They should be focused on the insight, on the actions, on the data science, so to speak. And instead they're focused on what some would consider the data engineering aspects.
Yeah. I think and that's what's crazy about that statistic is that statistic has probably been the same for about the last decade or so, and actually that fits in with one thing I'll say, which we're kind of skipping over, and that's fine. Is leading up to sort of page 12 in the book, there's a few pages that kind of describe kind of the history of kind of how we've got to where we are. You know, the rise of the warehouse. The rise of the lake, the rise of the data lake house, and to some degree the mesh, and actually, you know, you talked about who this book is for and the lens you look at it. I think actually, and I don't want to give Joe and Matt like a big head, but I think those 3 or 4 pages are really useful for someone who's not been in this space. You know, just to give that, why do we do things in this way? We do things in this way because we did them in this way in the past, or we did them the other way and they didn't work, and so we switched. So I think I just thought it's quite those pages. I kind of looked at it, and sadly I thought, cracky, this documents my career. I'm getting old.
That's a good call out. I did skip those pages, but there's a lot of great content in there.
Yeah.
Let's see where we go from there. This is another key thing that I pulled out is, again, going back to the scope of trying to understand the broader activities and responsibilities for an engineer. If you want to be in data engineering, you have to understand every one of these elements, right? And if I'm a data engineer, some of these things might be surprising, right? Cost, really? You can optimize for performance, optimize for cost. Interoperability obviously is the one that we all struggle with, but I mean, and there are no surprises here, probably not worth discussing quite a bit, but it certainly lends an idea as to how mature and frankly how savvy a data engineer needs to be. It's not your typical engineer anymore. They need to understand their business, they need to understand the cost, and they need to understand the underlying architecture.
I 100% agree. One thing I would say, and you know, I'm conscious of time, is you can't optimize for all of these to the same degree, right? Because you know, agility, if you want to be agile, typically what you do is you may lose some of the work that you do around making things more robust and reusable. You know, so some of that you can't. I think these are all important, but I think it's also worth being aware that you probably will optimize to some more than others, and that's fine. Just be aware of that. You know, you may optimize for simplicity, right, by putting all your data in a single thing, but then you're losing interoperability.
Yep.
Right.
Well, if I were speaking to a group of data engineers and I were talking about data mesh, I would start with this slide and I would try to articulate in as fair and balanced a way as I could how I think a data mesh could help them in every one of these areas. This is a hard job. Yeah. This is how a data mesh might help. Maybe not overnight, but certainly over a longer term commitment.
Yeah. That sounds like a slide for the future.
Let's do it. All right, we're getting to chapter 2, and this starts to get into because you pinged me a ton about this diagram. I think you got a T-shirt made out of it, but this kind of
It's
starts to
on my
jump into
whiteboard.
the actual data engineering lifecycle. And I pulled some quotes, not because we need to read them all, but there was a lot of, I just really enjoyed this chapter. There was a lot of great content here. I'm already reading chapter part 2,
Mhm.
and in part 2, it comes back into this as well and provides even more depth. But yeah, this really resonated with me in 2 ways. Again, I'm thinking about it from a CDO lens. One is it was really helpful for me to think about the framework. And I've
Mhm.
seen various different frameworks for how engineering occurs. This necessarily wasn't a surprise, but I like a standard. I think if we could all start to use the same framework or the same standard to describe the life cycle, that'd be fantastic. So I love the standard. Number 2, when I start thinking about the challenges that we're trying to solve with a data mesh, I think that middle part is where we're overrun. The middle part is where we're trying to create autonomous teams. That middle part is we're trying to create some more self-service. To me, it was very easy to relate this to some of the capabilities of a mesh. But let me step back for a second, Andy. What you love this? Tell me why.
So there's a few things. There's a few things on this, and also I love the undercurrents, which I know we're going to come on to on the next slide. But there's a few things, right? So that central box in the middle, that clearly delineates that's what the data engineer is responsible for. They're not responsible for the generation or kind of the consumption, right? This box in the middle is really where the data engineer focuses. If I'm being critical for a moment, I think that this is very much a left to right flow. But actually, you're going to iterate through this, right? So you're going to iterate on ingestion for a while, iterate on transformation, maybe go back to ingestion, right? You're going to iterate in serving, maybe go back to transformation, maybe go back to ingestion. Whether you're building a data product or you're building a data mart or whatever, those 3, getting data, doing stuff with it, sort of adding business value through transformation, giving it to people, that's kind of key. Storage was interesting. Because I thought I looked at this and I thought, crikey, that storage box is big, right? That sort of suggests that it's important. And I sort of, when I first looked at that, I thought, yeah, I think that's too big. I think there's too much emphasis. But then later on, and we'll get to this, maybe in the next call, you realize that actually storage is more important than it probably has been in the past because of the plethora of options that we now have. We maybe 10, let's say 20 years ago, we stuck our data into a proprietary storage format, and that was it, an Oracle or Teradata or whatever. And then we moved to Hadoop, and actually Hadoop brought a few things with it. So things like different file formats, right? Different file formats. And also we still had, those data platforms that I just described. And then as you move forward, we introduced things like streaming, right? And also table formats as well as file formats, and then object stores. And on-premise and in the cloud. And actually, so I guess what I'm saying is actually storage becomes just more. There's more choices, more options, more things to determine, more things we have to consider to ensure we make the right decisions in terms of data storage across those three steps in the life cycle. So I think there's a lot that you can take from just this picture.
Yeah, I'll pick up on 2 things. One is I don't disagree, but I wanted to add some color to that, where it says right under ingestion, I highlighted where it says source systems and ingestion represent the most significant bottlenecks. And I think that's right. But here's what happens, right? So I've seen this with customers. I saw this myself, right? Your first bottleneck is just trying to create those pipelines or trying to create connections to the back end, right? That's like an incredible bottleneck everybody appreciates. When you solve that, and when we're able to solve that for customers, I always say people get promoted. But then immediately after you solve that, a new problem arises, and that's the transformation problem. Because then your transformation teams are overloaded. Now that you've got the data, I've got all the fuel I need, I can't keep up with the transformation. And so in effect, your transformation teams, if they're already overloaded with bad pipelines, just wait till you open up those pipelines. Now they're going to be really overloaded. So I think, again, not trying to pull everything back in data mesh, but I really like the concept of saying, great, we've got the connectivity, we've got the back end of it, we accept the decentralized architecture. Now if you really want to get the bigger win, you've got to create these autonomous teams using self-service tools that are going to really drive you forward. Otherwise you're going to still have a bigger bottleneck in the middle.
100%.
Awesome. Here's your undercurrents. I'm not going to steal your thunder. I'm going to let you talk about the undercurrents. I think you had a challenge.
Yeah, so I did. So I must confess, when I first looked at this, I thought undercurrents. That's a weird name for some of these things on here, right? So
Did you lose something out there? I see you
yeah,
looking.
sorry, I'm sorry. I just someone just came in and said they were looking for something. I don't have it, so it doesn't
Maybe there
matter.
was an undercurrent that took your chair.
Yeah, apologies. So I thought that's a weird name, and I tell you, the one that stood out for me as a weird name was data management. And that's because, again, I've been around for a long time, and we used to talk about data management in the way that people now talk about data engineering. So, data management historically has been getting data, transforming and serving it. That was kind of the way we kind of described it. And so this was the challenge I had was, well, data engineering and data management, are they not the same thing? And actually, kind of having read this and on reflection, actually, I think there are a lot of the skills that we had in data management, some of them have become sort of data engineering, but actually they still exist, right? So things like data modeling, I think, is still vitally important. Is it a data engineering responsibility? Probably, maybe not. Maybe you have someone who's doing sort of more what I would call data architecture. So I must confess, I don't like the term undercurrents, but I did sit down and think, can I come up with a better one? And I couldn't. So it's kind of as good as any. But what I like about this is when we think about that flow from left to right at the top in terms of the life cycle, what we're basically saying is every time we make a decision, we have to consider security, data management, data ops, architecture, orchestration, software engineering, etc. And so there's going to be maybe things that we have to consider in terms of operationalizing. There may be, that we have to go and talk to people who have other skills, or we have to coordinate or collaborate based around these things. And I think I think this is really important, because what this shows us is the complexity that we start thinking about with data engineering. That picture at the top on its own is quite simple. When you then start thinking about, well, what about access control? How do I get access to those source systems, like you said, right? That's quite hard. But once I've got access to them, what data should I have access to within them? What data should I, once I've transformed and enriched the data and whatnot, when I'm serving it, what people should get access to what data? And you can go through each of the undercurrents, and I won't for time, but you can go through all of those and you can start asking questions kind of at every stage and go, how does this work? And what does that mean for this? And etc. So I think this is awesome as almost like an aid memoir. You're at a particular point. What are the things you haven't thought about? And this helps you sort of guide some of your thinking, I think.
Yeah, I'm being honest. It took me a little bit to understand that. At first, I was like, it's really great. As a CDO, I would love data engineers to absorb these responsibilities. But then as I read further, I don't think they're saying we're responsible. What they're saying is these are things that we as a data engineer need to be closely connected to. Okay, so
Yeah.
okay, that's still good. I think in big boxes, right? So I naturally came back to just, okay, I develop or build. So I develop, I operate, and I govern. And so then, okay, so what fits under where, right? And then I would say, okay, so under governance, I've got data management and security. I'm missing maybe change management. Maybe that fits under operate, maybe that fits under development, but I think it's probably under somewhere. So I think there are a couple subtle things that are missing here, but I think it's a great step forward. And to be honest, I think most people would say it's probably too much. But I think the argument that Joe and Matt, I think, are trying to make here is that a data engineer, don't think this is an exhaustive list, but a data engineer needs to understand the full ecosystem if they're going to be successful. They don't own the full ecosystem. They may not necessarily influence the whole ecosystem, but they have to understand how their architecture fits into it. Otherwise, they're going to have bigger issues. So I think that's the message. Yeah.
Yeah. I think it's cool.
All right. Chapter 3, designing a good data architecture. Ooh, this is the hard part. Now we're getting to the good stuff, huh?
Yeah, let me skip through to my pages. I like to go back to my pages and my notes and things as we go through these. So, yes, what is a good data architecture?
I highlighted some pieces that I thought, I mean, again, going not to kind of hark everything back to a data mesh necessarily, but common, widely reusable set of building blocks. Boy, it sounds like a data product, right? And so there's a lot here I think that we can look at and say, yeah, we're on board completely.
Mhm.
The second piece there, we talk about agility, right? Good data architecture is flexible and easily maintainable. That's hard.
Yeah.
I think we took a big step forward, most of us, when we moved into the cloud, and that created a level of standardization for all of us. And so now the idea of keeping our kit up to date, so to speak, hopefully no one's running NT anymore, because you know what, the cloud doesn't run it, right? And so everyone took a step forward in standardization, which brought a level of reliability, a level of security, and some economies of scale for cost and so forth. So I think that that's true, but as I say that, in the back of my mind, I'm thinking about that picture that Joe and Matt like to
Mhm.
put up on the screen with the 2,000 vendors, right? And so then it's like, well, yeah, if good architecture is flexible and easily maintainable, and I've got 2,000 options to pick from, it's impossible, right? So it seems like it's a really,
Yes.
really hard thing to achieve.
Yeah. The thing you said about the products with respect to good data architecture, I think is quite an interesting comment. On our previous session where we were looking at data mesh in practice, one of the things that they suggested was you build out your self-service infrastructure for data mesh with using product thinking. So you look for the capabilities you need, you build those capabilities, and you kind of stepwise build out your infrastructure. And it's very much product, feature, capability requirements drive that. And I think that kind of fits with this, right? You're looking for things that you can reuse that meet the requirements that you have today. And that's kind of so I read the good data architecture definition here, and I think back to the data mesh and practice conversation we have. And actually, it's interesting that I think there's quite an interesting tie-up between those two. They fit together really nicely. I do agree with you that figuring out which components to use across sort of 2,000 odd technology solutions is sort of really hard. I also like the world is fluid comment, because and I think this is where technology, sort of abstracting technology away from the folks who need to be business and data literate is really important. The technology we have today is not the technology we're going to have in 2, 3, 4, 5 years. It will change, right? That's without doubt. And it may change more quickly. We may discover that we can do something better, cheaper, faster, whatever. But we don't want to. I don't think anyway. Architecture should impact the consumer of the data or the data product developer. So if someone is building something, they shouldn't be slowed down by the fact that we're switching technologies. They should be able to just keep doing their thing. And I think that is kind of important. So enabling the agility while being able to change maybe where the data resides, for example. We shouldn't be impacted by where the data resides, and we shouldn't be impacting our end users and our decision makers. And to me, I think I would go further than perhaps Joe might have gone.
If we were sharing a whiskey and we're speaking truths, I'd lean forward and I'd be like, look, here's the reality. Like on the back end, you're in constant change, right? There's all kinds of reasons why change is occurring. Forget the technical reasons. You got compliance issues and all kinds of, you got cost issues, you got acquisition opportunities, you got all kinds of reasons why the back end is going to continue. So you have to adopt or embrace the fact that that's changing. On the front end, you have to find a way to keep that stable, right? I think in the 90s I used WordPerfect, and then for 20 years of my career, all I ever used was Microsoft Word, right? And PowerPoint, right? And last year or two, I've been using the Google Suite. But once I get a tool that I like, I stick with it, right? And so I think on the front end for the consumers, they're going to get tools they like, and they're going to stick with them for a long time, whether that's a Tableau or Power BI or something like that. Data scientists, I think, as well. So what you need is something in the middle that's going to allow you. And again, I sound like I'm reading the book again or preaching the book again, but you something in the middle to abstract that constant change in the back from the front end. And I think
100%.
that's the key here. Yeah.
Yep.
Something like Starburst. Okay, but it's awesome. Let's move on to the next one. So I like this. I didn't want to, or I didn't have the time, obviously, because we only got limited time today in the discussion. They go into great detail in the book about each of these principles, right? And we talk about each one of these. And I certainly recommend everyone, like I said, even every CDO should go out and take a look at this just to make sure that we understand. But and some of these are pretty obvious, right? Plan for failure. Yeah, okay, that makes a lot of sense. But I highlighted a couple that I think are just worth discussing. And let me make sure before yeah, perfect. Yeah, I want to make sure I didn't separate them. So let's chat about these, Andy. These principles of data engineering architecture.
Mhm.
The first one, choose common components wisely. Okay, that makes sense. What does that mean? I think the word interoperability isn't on there, but I think the idea is if you have a component that's going to have to work with everything else, be careful about what you pick. If it doesn't connect, you're going to have issues, right? So the common
Yeah.
components need to work.
Yeah,
Need to
so
integrate.
I'll give a quick example of this actually. So, um, like the Hive Metastore, right? It's a metadata repository that's been around for a long time, and you kind of I when you talk about it, people roll their eyes, but then you realize that essentially AWS Glue, right? It looks and feels like a Hive Metastore. Microsoft Purview, to some degree, looks and feels a bit like a Hive Metastore. The Dataproc, Google Dataproc, exposes a thrift service that looks and feels a lot like a Hive Metastore. And once you have something that kind of interoperates like a Hive Metastore that's been around for a long time, pretty much everything can plug into it. I'm not saying you should immediately go out and deploy a Hive Metastore, but if we think about having something that integrates or looks like provides the same APIs as a Hive Metastore, what we know immediately is lots of things can plug in, right? So I think for me at least, this is one of the dimensions that would come into my decision making when I'm choosing components. What can I integrate with? What does it look like? What other things work around it? Exactly, interoperability. I think that's really important.
If we stole this page from their book and then we stuck it in a data mesh book and we retitled the chapter "Principles for Creating a Data Mesh Architecture," it would make sense. It would still make sense, right? Choose your
Yeah,
common components. Choose
yeah.
your, how are your catalog or your data mart or your metastore? That's a common component. Be careful how you pick that, right?
Mhm.
So I think these make sense. Same thing for architect for scalability. Indeed, right? I think oftentimes, right or wrong, and I certainly appreciate the value of an MVP. I am a supporter and strong, I have a strong voice for starting small and moving fast. But even when you start small, make sure that you're picking a solution or an architecture that's going to scale, because what happens sometimes, if you're lucky, that starting small creates a big win. That big win creates momentum, and then you don't want to say time out, let me replace it for another tool, right? So
Yeah,
you want to
yeah,
think
yeah.
about that scalability, about concurrent users for data products, the performance in the back end, and so forth.
Yeah,
This
I think there's, sorry, just on that one, I think there's other dimensions as well. So it's like scalability of change almost.
There you
So
go.
it's being able to scale to different requirements of end users, and that you may not think that fits in there, but I think it probably does. Right? There's nothing on this
Oh,
list around agility, but
yeah.
being able to scale for the requirements of a business, let's say a SQL user today, and then maybe or maybe a business analyst today and a data scientist tomorrow. Right, that to me is sort of sits under that. We need to architect for not only their workloads but also their kind of interactions and their kind of use cases.
I like how you're going with it. You're taking a couple of different lenses on it. Let's do the same
Mm.
thing with number 6, build loosely coupled systems. Because what I initially thought about,
Mhm.
as I was reading it, I was daydreaming about data products, because I firmly believe that it's really important that we need to build loosely coupled data products.
Mhm.
You've heard my speech on those dependencies.
Yeah,
We have to
yeah.
be very careful at how we tie them together. I
Mhm.
know this is largely in the book. We're largely talking about the architecture components themselves. You
Mhm.
move all your data from one spot to another and lock it in there, and then it's not loosely coupled. That's an irreversible decision. But I think that idea of loosely coupled systems goes beyond just the core architecture.
So and maybe this fits in 6 and 7, but I think an example here is when you're thinking about data storage, right? So let's say we put our data into into a proprietary, cloud data platform. That is difficult to reverse, and it's kind of tightly coupled, right? You're tightly coupling your data with your query engine. Whereas if you were to make a decision where you're putting your data into, an iceberg or a Parquet or whatever kind of makes sense for your initial requirements, you can reverse that pretty quick if you decided that you've got the wrong file format. But also from a loosely coupled perspective, you can hit that data in that format with maybe open source tools, maybe with commercial tools, maybe with different workload, different usage, again, machine learning, maybe through some sort of API, maybe as a stream, maybe through SQL, etc. And so, when we say loosely coupled, people are immediately like, oh, APIs, I'm going to have some sort of contract, and if this changes, then that's cool, and we can still manage. I sort of I guess taking that different lens is, to me, this also is kind of that thing about being open and making sure that we don't make a decision that's irreversible, but equally we're not coupling proprietary storage formats, for example, with engines. I think there's quite, these are really interesting sort of statements that we can take in different directions.
I want to, before, again, I don't want to, we went on the slide too long, but I really like the list. Two quick things. One is, I think they missed, if I were going to add a number 10, I would add something around architect for the end user or architect for user experience. You can't create this list and completely miss the end user. Number two, FinOps, I didn't highlight it. I really liked what they talked about there in FinOps. It just doesn't fit with our storyline today, but I thought it was a really good add to the list. I'll leave it at that.
So what I would say is, anyone listening, read the FinOps piece, go off and have a look on Google FinOps. It's not just about sort of cutting cost in cloud. It's more about, in my opinion, anyway, it's what the new computing, sort of elastic computing, scalability, etc., that cloud platforms provide. It's the new opportunities that you can sort of drive with that new, scalable architectures, and how much you can make and how much you can save, etc. So it's not just TCO; it's also ROI. That was a bit of an eye-opener for me. I hadn't really looked into this space.
For anybody out there who's TBM certified, technology business management, you'll recognize that as kind of a core concept for TBM management, running IT like a business. So awesome. Anyway, let's move on, because otherwise we'll get stuck and we come in way too late. Highlight obviously this page and this section, because we're talking about domains and services, and of course the obvious thing is think about domains and data products. I was trying too hard to force the concept of domains and products into this example, and I had to sit back and think about it. And there's certainly, without a doubt, there's some synergies, but I think there's a distinction between the services we're talking about here and data products. And that's a key difference, because we're talking here about services, which could be in the form of an application or a microservice. And it's not necessarily, doesn't fit the perfect description of a data product. Which is okay. And I'm just calling myself out for making that mistake, trying too hard to force the two concepts together.
No, I think that's fair. I mean, it is interesting, the domain piece, because it does, to me anyway, it maps really tightly with the concept of a domain in the Zhamak, Dagani data mesh world. So I kind of agree, and I agree that the services. The services are interesting in this space, and this was probably another kind of debate over whiskey in the bar, but or gin. But so I think you can make the case either way.
Tequila has no sugar and no carbs, but that's a different conversation. But the reason I highlighted this and kind of this I don't know whether that's pink or salmon, whatever color you want that to be. But here's nothing to do with mesh, just personal experience. I came from an strategic consulting for 13 years, and then in a corporate role for 10 years. And I spent most of my career customizing process and technology. And a great leader taught me about 5-8 years ago, challenged the concept and said market standard is the way to go. And I think we started heading down an approach where we would say, if it's good enough, let's use it, right? So why does it have to be, why do we have to customize everything? And we started picking the areas of our company where it made more sense to apply a market standard, right?
Mhm.
It's good enough for Walmart, right? Let's go do it, right? So I don't know necessarily that this idea of where cutting and pasting effective process is a bad thing. I think you look at your process and you ask yourself, is it worth customizing? If it isn't, and I think that's true for anything, whether we're talking about business process or data engineering process, it is okay to standardize. You don't need to go customize. There's nothing wrong with a cookie cutter process if it's good enough. Anyway, sorry, let me get off my tangent.
Yeah, so I'm just going to add one comment and then we'll go to the next slide on that, because that's an interesting comment. But I think that goes beyond data engineering, actually. That this is sort of, I guess, general management. But I think you probably customize where you see competitive advantage.
That's
That will
exactly
probably
the
be
point.
the driver. Do you need I'm aware that I'm just about to put my head above the parapet and be shot down by HR people, but do you need a unique HR system for your company? Possibly not. But do you need a unique, I don't know, sales experience?
Yep.
More than likely.
Hello Salesforce, hello Workday, hello ServiceNow. That's exactly why those SaaS are in existence. Yeah. Anyway, we're way off topic. Let's pull us back. Tight versus loosely. I put both on the page, and I want you to maybe argue with me on this. So my initial gut is to say, okay, we don't tightly coupled is bad, but that's when I see you sit back and think about it. And if I'm designing a data mesh in some domains, I'm going to have tightly coupled data products, or data products that are built in a certain sequence that are built with core dependencies. I may have a different domain that's going to have data products that are much more loosely coupled, maybe a discovery domain, or maybe it's a different kind of domain that's serving a different purpose. So I think I don't know that, obviously I would prefer loosely coupled. It makes it much easier to be agile. But I think when you design your data mesh, you have to you have to consider both. And sometimes you might want to build a more tightly coupled data product design. What say you, Mr. Munn?
So I took this in a different way, which was, which we often find ourselves at the other end of the spectrum. So way back when we started talking about data mesh, one of the questions that I got asked, and occasionally it still comes up, is how big do you need to be to adopt a data mesh? And I always think about scale of change, right? So scale of change on the source systems, scale of change on the usage of data, and also to some degree data literacy, I think, is important as well. Now, if you've got an organization which is basically doing, let's say, regulatory reporting, and the regulations aren't changing, and they're not going to change, and you're going to consume the data, and there's not going to be any different data systems, go with tight monoliths. Just, it's going to be faster, cheaper, easier. It's going to be optimized, right? You stick your data in one place, you have tightly coupled application code, buoy boots, right? That's probably going to be as efficient as you possibly can be. If, however, you're in an organization where you're onboarding new and different data, or you want to exploit new and different data that you've got in your environment, and you've got end users who are pushing the boundaries and doing new and interesting things and applying new machine learning model techniques and whatnot, and therefore need sort of data in different formats, or need different data, then I think you need to get much more agile, and you need to move away from the tight and much more towards the loose. And then we, that sort of fits much more with the data mesh sort of agile approach, I guess. Microservices are kind of really interesting, I think, because to some degree, I look at microservices and I think, why are we talking about microservices in a data engineering lifecycle? Maybe this is a question I'll pose when I meet Joe Rees and he knocks me out in the ring. Because what are we really doing there? Are we wrapping up data as a microservice? Because if we are, that feels like it's a kind of a future vision of what a data product might be in a data mesh world. Is that what we're doing? And then are we thinking that we're going to link those microservices together to form other microservices, and actually this just becomes data products, and the microservices are the kind of the service APIs? I don't know. And I feel like that, there was a discussion about microservices in the book, and there's nothing wrong with that. But what I'm kind of interested in the why. Why would we think about microservices sort of wrapping around data? What's kind of the benefit? Sounds cool, but what does that get us? And that, I'm not sure I'm on board with that at this moment in time. That's a controversial statement, I guess. Maybe, I don't know.
Now, gosh, no, not enough time and not enough discussion.
Yes.
I wonder, and you may be further along in the book than I am. I don't know that this chapter went deep enough into microservices. But let's see if they come back later. And I think you're right. When the show ends, I want to talk more about your upcoming challenge with Joe, because is microservices going to be something you have? Maybe I'm giving too much away here, but
no.
is that going to be one of your
we'll be sort of.
Is that going to be your jab, the microservice?
No.
No, okay.
No, right. So we're going to be just sort of. I don't want to give too much away, but the conversation or the debate, the fight, will be in the general space of data mesh and data engineering. I don't think microservices will come up, although that may be his attack on me if he sees this beforehand.
Yeah. All right. Let's kind of getting closer to the end here. I mean, we got through a couple of different types of data arc. I did create a slide for everyone for the ones that I've highlighted here, just because I think they're really relevant. I obviously, it's, if you don't know what a warehouse is or a lake, read the book. These are must have, so to speak, in terms of knowledge base. You have to know what every one of these are. Lambda and Kappa, I don't know. Sure, it's worth knowing, but I really wanted to dive into the convergence piece, the modern data stack piece, and the data mesh. And so I broke those out specifically. I'm starting with this kind of convergence, this next generation data lake and data platform. This it reminded me real quick, and again, I'm going to go off a crazy tangent, but back in my old security days, I remember when they first came up with the first next generation firewall, and we were all excited. And then somebody came up, and this actually happened. I'm not making this up, the next generation firewall. And then it was at the end, the last one, there was a next. And wow. And I remember having the conversation with that sales rep as a security architect thinking, are you serious? Y'all couldn't think of a better name than next? So I hope we don't see the next generation data lake next year. But I thought this, back to your point earlier about the history of how we got here, I thought this chapter was was well written, or at least this kind of page 105. There was a lot of good content there. I highlighted this notion of separating compute from storage. They called that out as being a great thing. Yeah, absolutely, right?
Yeah.
I know a company that does that.
So I think this is interesting, because what this really leads you towards the concept of the lake house. And really the lake house to me it's trying to take the best bits of the data warehouse, where we have the ability to kind of update, and we have the ability to query and model and shape our data, and the best bits of the lake, which is really where we have infinite storage capability, and we have that separation, and to some degree this has really been made possible by new table formats that have kind of come about over, I guess, the last, I say I'm going to say a couple of years. I mean, they've probably been around longer, but in terms of kind of companies actually adopting and using them, maybe longer than a couple of years, to be fair. And I'm thinking about things like Delta and Iceberg and Hoodie, which really give you that give you the ability of the data warehouse, but on sort of lake infrastructure. So yeah, next generation is interesting. Because you're right. What I'm interested in, what comes next. What will be the next generation? I don't know. But I think it's interesting, because it feels like it's a very technical, very small thing. These table formats, but they have a significant impact in kind of the way we're going to do architecture sort of going forward.
Well, and it calls out the idea that the back end is going to continue to change. You're going to continue to have this convergence. You're going to continue to have this innovation. Capabilities are continue to grow. They're not, I think, I hope I don't misquote the book, but I think it's something like these are going to be around for another 10 years, if not more, right?
I think more, yeah.
For a long time.
Yeah.
And so again, going back to the idea of trying having needing the agility to be able to connect to all that, I really love the idea of a virtual data warehouse, right? Being able to query the data
Mhm.
where it sits and you put it together where you want it with speed.
So I'm gonna pick you up on this, right? If you go back and look at Bill Inman, so Bill Inman is the father of the data warehouse. He wrote the book. He all that good stuff. There's not a single place where he says you need to centralize data. He talks about integrated data, but it's at the data level. He does not say it has to be on a single platform. I think that's something that vendors have come along and they've gone, you've got to put all your data into a single thing, and we're going to call it a warehouse. That's not what that's not what the original intention of a data warehouse. The original intention was, you would have essentially, data that was integrated across the subject domains at the appropriate level of detail that people could basically use. There's nothing about the storage layer. So I would argue that every data warehouse could be a virtual data warehouse, because to me, a virtual data warehouse is basically just the data, or if you like, the data modeled on wherever it resides, whatever storage. Just a small argument to a point. I'll get off my soapbox.
Yeah, no, spot on,
So,
spot on. Awesome. And then we get to the modern data stack.
yeah.
So initially I was really critical of this and I was like, you could have done so much more here. But then I sat back and I said, what do you draw? What do you say? Because it's in flux, right? And so I think and Joe and Matt are much more experienced, and they're obviously they're experts at this topic. I don't by any means mean to pretend that I know any better. But with a CDO lens, I was really curious to get to the chapter, and then it was like, I was expecting to see a little more, but again, I think everything's in flux right now. I think you have to draw big boxes and you have to try to explain how the big boxes interact, which they've done really well, and then kind of sit back and let it evolve a little bit. Yeah, yeah.
So I look at this and I think this is exactly the same as what we had in the 90s. Right, it's the modern data stack. All we've done is so in the 90s we did all of that. We didn't have the word cloud, and in the 2000s we had all of that. We didn't have the word cloud, and then in the mid 2010s we had all that, and we probably had cloud. So I look at this and I think it's modern technology that does the same thing that we've done for 30 or 40 years. I'm not a big fan of the concept of the modern data stack. I actually think we're hurtling towards post-modern data stack, if that's a thing. This to me is it's the nonsense of repeating the mistakes of the past and expecting a different result. However, in terms of the book, and that's just my opinion on the subject, in terms of the book, it's well described. It talks about kind of the fact that you bring these things together. It reduces complexity. It's relatively straightforward, and it works. It's just that there's no innovation here at all on the kind of the way you're working with data. The innovation is in the technology stack, I guess.
And going back to data mesh, I think I like how they call out specifically the notion of self-service has to be a key element of any modern data stack. And so that's so credit to them. I think they focus and they kind of hone in on that point. The other piece they come back to and they talk, and there's in several places, I've highlighted one or two here on the page, but they talk about open source a lot. And I know in the latter chapters, they also talk about open source when they're talking about making the right decisions. And so that's really interesting. And the reason they reference open source is, one is the speed of innovation, but two, the community, right? The ability to be able to not only take part in the development, but also push forward ideas and push forward features. And so the modern data stack call it as a fluid, fast evolving, community driven environment. So I was like, and when you read the text, you're like, yeah, that feels good. I just don't know. I'm with them. I don't know what picture to draw. I don't know that I would draw a better picture, but I think it's coming. And then finally we get to our favorite topic, data mesh. I was expecting a whole chapter on this, and we got like a page. But to be fair, you corrected me. It comes up later in the book as well.
Yeah.
So yeah, I think it's good, good on them for covering it. And I think it's a balanced approach, right? And there's nothing negatively is said about data mesh. It's offered as a consideration, offered as an option when you start thinking about how to design, which is exactly the right way to present it.
Yeah, I think I mean, if I'm being critical of Matt and Joe, and let's hope they never see this, but if I'm being critical, I'm not really sure that data mesh sits alongside the modern data stack or Lambda and Kappa. I just, Lambda and Kappa is very much these are different ways of
that's a modern technology stack.
Exactly. It's all technology. Kappa and Lambda are, you could say there's a little bit of ways of working because you're combining real time and historic and whatnot. But it's technology approaches, and modern data stack is technology approaches. And I think again, of being critical, I think data mesh stands slightly to the side of that because it introduces there's a large organizational and people and kind of ownership and motivation, incentivization, and governance structures. It's a very different approach, and it requires, I would argue, different technology. But it starts with kind of the thinking and the ownership and the what you're actually doing, I guess.
The others are the apples. They gave us a basket of apples, and the data mesh is the avocado. It's richer than the apple, but there you go. Yeah, it's easy to spot out. Indeed.
Yes.
All right. We only have one slide to go on chapter 4. Chapter 4, and I say this because I want to make sure people don't misunderstand that I didn't think it was valuable. It was super valuable.
Mm-hmm.
I couldn't think about how to go into all the detail. And so I decided to keep it fairly high level. But chapter 4 is largely around choosing the right technology. And so this is a simple view, an overly simplified view of a great chapter.
Mm-hmm.
I'll pause for a second. Because there's a lot of text on the page. My apologies. I don't expect the reader to actually read everything. On the right side of the page, some of the things that I've highlighted, I think are really especially important. Again, if you think about this from a data mesh perspective, if I'm building a data mesh, how do I choose the right technologies? Everything on the list is relevant, every one of them. But I think I wanted to call out a couple, and maybe we'll just take turns in the interest of time. I'll start with speed to market. I love that they said speed to market, not query speed, not API integrate. Speed to market is about your ability to deliver to the business, right? And keeping up market pace. How fast can I deliver something to my business teams and then have them actually execute it? So a solution to the business. Speed to market is really important. And when we create autonomous teams in data mesh, those autonomous teams are focused on that speed to market. Interoperability, Andy.
If it's all right, I'm going to skip over that because we've talked about interoperability quite a lot.
Fair enough.
And I'm going to drop to custom optimization business value.
You can pick anyone you want, Andy. I'm sorry. I didn't
okay.
Don't put Andy in a corner.
No. So in which case I'm going to switch to location and maybe because you may have a view on the cost optimization. So I think about location here. And this idea of choosing the right technologies, right? Should we go to the cloud? Should we go to on-prem? Should we do some combination of cloud or on-prem and in the cloud? And I think there's the reality is we don't have greenfield sites. Everyone has stuff. So it's like that old adage that if you're lost and you say to someone, how do I get to London? The first thing they'll say is, I wouldn't start from here, right? So everyone is starting from a place where they've got stuff. And so I think with location, it's not like you can just go, well, we're going to go everything to the cloud because we've got all this stuff on-prem, maybe. Right. So we got to take that into account. But I particularly like this and think we as individuals in this space, we need to start thinking about the reality of the world. And the reality of the world is that probably for the next period, most organizations are going to be hybrid cloud, right? They're going to be a combination of on-prem data processing and data in the cloud data processing, and maybe hybrid multi-cloud, right? Where we've got multiple, we may have some data on Amazon, some data in Azure, and some data in a Hadoop cluster on-prem. And what do we do with that, right? And choosing technology that enables us to operate with the data distributed in that way. over the long term, when we're talking about immutable rather than just transitory technologies. I think that is a really interesting and important sort of thought process to go through. The idea that we're just suddenly going to put all our data in the cloud is, I've not seen anyone do that, and even the companies that say they've done that, it's sort of in the single or maybe even low double-digit percentages of data. So I think location is really interesting when we're thinking about choosing the right technologies.
Wow. Yeah, you covered a couple there and there.
Yeah.
That's a
Sorry.
great answer. No. It's solid. I want to, let me pick one more. I want to go back to, I think, to cost optimization, only because I think when you first start thinking about the mesh, the way that you should think about cost optimization or plan your FinOps model is you want to leverage what you've already got as much as possible, right? If you're going to have to spend a lot of money to transform and migrate to build a mesh, that it's going to take too long, and maybe you missed a point, right? Because you'll never stop migrating. Not to say you don't have to, it's just saying be smart about what you migrate. So the other thing to think about in the cost optimization side for a mesh, when you start to choose the right technologies, is understand that you're about to enable autonomous teams to do their own analytics. That demand is going to grow very, very fast. And so if you don't plan for that, if the cost to do analytics today in your current environment for your science team costs a lot of money, just imagine what it's going to cost when you start to enable these business teams to do it on their own. And so when you start thinking about the TCO of that end-to-end process, you want to make sure that it's going to be affordable. The value is there. Let's make no mistake, right? Enabling teams to do their own analytics, these autonomous self-service teams, the value is there. And if you can kind of manage the cost point, that you're going to have even greater value and you're going to have even greater adoption. So think about that, right? Think about that longer term cost optimization for how you create data products, how you operate data products, and ultimately how much you're going to allow these teams to do on their own. Are you going to give them the keys to compute, so to speak? Anyway, I think that's a lot of great content here in this chapter, and there's even more great content coming up in the next part, in part 2, which we're going to cover in our next session, Andy. And so I hope we'll get more people join us. Any closing thoughts? Just to kind of go back to where we started. I said every CDO should read this part 1. I think that's true. You with your data engineering lens, I think you, as a CDO, I'm left thinking that was pretty good. That was really, really good reading. As an engineer, what are you left thinking with?
So I've kind of read ahead, right? I'm
you want
aware
more
of what's,
detail. You want more content, and it's coming, isn't it?
Exactly. So I think of that next level down in the different, the different phases of the life cycle. That is kind of, I'm kind of left wanting more, I guess. But I think, as I said at the beginning, I think this is a really good book for anyone who just wants to understand kind of data engineering. If you're, I guess, even if you were like a university student, right, you've just got your computer science degree and you're moving into your first role, a lot of, and it's kind of in the data engineering or data science space, this is, I think, really good context, because what you're getting is the output of, or the distillation of kind of people's experience over a period of time. And that's when I think about that, that's kind of gold dust, right? Because you build up experience over time, and that experience helps you make more informed decisions. What you're getting here, certainly in this first chapter, or sorry, this first part of the book, is a lot of, I think, kind of nuggets of gold that you can tie together and help you think more broadly. So.
Well said. Nothing better I can say that to close the session. Thank you, everybody, for your time. We'll continue the chat on LinkedIn. See you for part 2 coming in soon.